Okay, let's go ahead and finish up this 2D that we were doing on a separate sheet of paper. So 3 came out. There were 2 3s, so that's 9 times 3 radical 5. A 5 came out, so that's 9 times 5 radical 5. A 2 came out here. Another 2 came out, 8 times 2 times 2 radical 5. And I see they're all like terms. That looks good. Remember, if 2 of them are alike, which I think is on the test, you combine those 2 and then just leave the third one. But on these, all 3 are alike, so we're good to go. So 9 times 3 is 27 radical 5, minus 9 times 5, 45 radical 5, minus 8 times 4, 32 radical 5. So since they are all like terms, we can go ahead on our calculator and type in the coefficients to see what the new coefficient's going to be. So that will be 27 minus 45 minus 32. And that gives us negative 50. Trying to fix the light. It doesn't look that good. So negative 18 and negative 32, negative 50 rad 5. That will be our answer. So negative 77 plus 27, yep, that's negative 50. And that's just like, I think it's about number 6 on your test, something like that. So very good one to make sure you have highlighted in your notes. If you have room to write it in your notes, great. If you didn't, be sure and write see other page. I'll go ahead and write that too. Okay, so then we have a couple special cases here that we're going to work on. So notice none of the ones above had any addition or subtraction signs under the radical, right? That's how I knew this was a special case. See how these have addition and subtraction? Well, unfortunately, we can't break it up and do this one and this one and this one and this one. You're not allowed to do that with addition or subtraction. So what you have to do is think, how could I turn this into multiplication? What did I do in chapter 4 to turn it into multiplication? GCF. Remember that? And look at GCF there too. Because once we turn it into multiplication, then we can break it up into separate radicals. But if it's addition, we cannot. So do you see a GCF of 49 there? Divide each of these by 49. And you get x plus 1. So that's just factoring using a GCF. Here the GCF is x squared. Remember, you always take the smallest exponent. When you divide each of these by x squared, you get x plus 1. Now that it's multiplication, now I can take the square roots of anything that has doubles. So this is 2 7s, so that's going to come out as a single 7. X plus 1 only has 1, so it's going to stay underneath. Plus, there's 2 x squareds there, so they'll come out as a single x. And underneath, x plus 1. So these are not like terms, so I can't combine them. But what Alex does is they take this out as a GCF. They go, oh, that's a GCF right there. So let's pull it out in front. And then what would be left once you take it out? Well, once I take that out, I have 7 plus x. So that would be my answer. You could really leave it like this. This would be fine. But like I said, I notice that Alex does this. They take the common factor out, another GCF, and then say, okay, it's gone from there, so what's left? 7 plus x. So I would accept either one of those on the test. Okay, F looks really, really scary, but it is not, I promise you. So when nothing's common, we break it into separate radicals. So let's do a squiggly here. And so we're going to break this into the 4th root of y cubed over the 4th root of 81. So there's nothing common. That's why I broke it into 2 separates. This already has the 3 outside, so we don't have to worry about it. There's no this is an index of 4. There's no groups of 4 here. There's no groups of 4 there. So I'm going to put a 1 here because I see we're going to have like terms. Minus 5 4th root y cubed over 3. So that one we can't do anything with. So does everybody understand why we can't break down the radical? There's not enough to get out of jail. Not enough to get out of jail. So really, this is our only piece we have to work with in this problem. So 81 is 9 and 9, which is 4 3s. 3 times 3, 3 times 3. So 4 3s are going to come out as a single 3, right? Because this says look for groups of 4. So does everyone agree this is all going to come out and there will no longer be a radical? There's nothing left under the radical because those 4 3s came out as a single 3. So this problem's going to turn into 1 4th root y cubed over just plain 3 outside minus 5 4th root y cubed over 3. So now we need to look and go, do we have like terms here? These are alike, these are alike, these are alike, and these are alike. Everything's alike. So we're going to pretend the problem was this, 1/3 minus 5/3. Do you all agree that would be negative 4/3? Well, for the same reason, this is going to be negative 4, because 1 minus 5 is negative 4, and then we just tack on the radical part, 4th root y cubed. So, and then keep the same denominator. So that one wasn't too much work, but that would give students a hard time on a test, I'm sure of it. But you're really just thinking like this. 1/3 minus 5/3 is negative 4/3. So see my negative 4/3, and then you just tack on the radical. Okay, let's do the last 2 and we'll be done with these notes. So this one is talking about perimeter. We have the perimeter of the building surrounded. So that means the whole outside. Do you agree? So we're not going to do length times width. That's area. Perimeter is all around the outside. So we can assume, I guess, that these are rectangles, so the opposite sides are equal. So to find the perimeter, does everybody agree I'd add all 4 of those sides? So perimeter equals x plus radical 20 plus x plus radical 20. I'm going to just draw a line here so we don't get it messed up with the last problem. Okay, but they gave us a perimeter. They said, oh, the perimeter is 24 radical 5. So let's go ahead and write that in. 24 radical 5 equals, we have some like terms here. 1x plus 1x is 2x. 1 radical 20 plus 1 radical 20 is 2 radical 20. Remember, radicals are just like x's, so whatever you did when you were adding your x's, add the front, keep the x the same, add the front numbers, keep the radical 20 the same. So what you should notice, hopefully, is that this is not simplified. 20 is 4 and 5, which is 2 2's and a 5. So we need to rewrite that as 2 2's and a 5. I like my x on the left, so I'm going to flip over at this point. So 2x plus 2, and then we're going to break down the 20 as 2, 2, and 5, and then set it equal to 24 radical 5. And again, I put that 24 radical 5 in because they told us what the perimeter was, so I put it right there. Okay, now we can simplify that radical, and that turns into 2. And remember, this is 2 times. So this is going to turn into 2x plus 2 times 2, which is 4 radical 5, equals 24 radical 5. Okay, now it's starting to look a little better. So I need to solve for x. See what the directions say? Find the value of x. So I need to solve for x, which means I need to get it alone, which means that needs to move over. So to switch something to the other side of the equal, remember, we always do the opposite, and we're allowed to add and subtract these because they are like terms. So we get 2x equals 20. 24 minus 4 is 20 rad 5. Remember, we subtract the front numbers, keep the radical the same. Almost have x, don't we? To get x alone, we do the opposite, divide by 2. So you can see x is 10 radical 5 and centimeters. So you're just finding the missing side, and they give you the perimeter. Number 4 is just like it, so why don't you go ahead and shut off your video right now and work it on your own before you look at me doing it. Okay? Okay, so this one gives us the perimeters 10 radical 2. So we know to add all the sides, because perimeters all the way around. It's not multiplication, it's adding all the sides. So we would have x plus radical 8 plus x plus radical 8, equals 10 radical 2. So I just added the 4 sides. So again, I'm going to combine like terms just like we did on the last one. And so then we have 2 of these, 2 x's, and we also have 2 of these, plus 2 radical 8 equals 10 radical 2. So that can't be simplified, but this can. 4 and 2, which is 2, 2, 2. So this is 2x plus 2 times 2, 2, 2 equals 10 radical 2. So we're getting close here. So these two 2's come out as a single, but we still have a radical 2 underneath. So this is going to be 2x plus 2 times 2, 4 radical 2 equals 10 radical 2.